Hello and welcome back to ProSum tutorial. My name is Alberto Marin and in this video I will show you how to assign loads to the structure and how to run analysis. We can take the model of the masonry structure we did in the past two videos. To assign loads, we have to go in load assignment context and we have to use some control panel. In the first phase of the analysis, we suggest you to run the analysis only with static loads. This allows you to check if the model is correct or not. So to define the static loads, we have just to click on this command, number 1, static loads. The program suggests us to define load combination. So we can ask yes. Since we have defined floor elements, loads are automatically applied to the structure by the program. So the self-weight of the structure, dead and live loads of the floors are full automatic. And also the load combination generation is automatic. For more information about load assignment, I suggest you to check other ProSup tutorials and ProSup and ProSum manual, user manual. With this command, we automatically define ultimate limit state load combination. So as I told before, we are not going to define seismic action, but we will run analysis and we will check the results. We want to understand if our model is correct or if we have some mistakes or problem in the model. To do this, I will check displacement and action on structural elements. With this command, I activate the control for load combination. The first one is to control the loads for each load case. And with this command, I check the deformed shape of the structure. To have a better view of the displacement of the structure, I turn off some panels. I want to investigate the displacement only of the element of the equivalent frame. I don't see problems in the displacement of the structure, so I can check also the action. As an instance, the axial action on the equivalent frame elements. Then we can control also shear action and bending moment on structural elements. If the results of the analysis are correct, so we don't see problems in our model, we can came back in load assignment context and we can define the seismic action. To define the seismic action, we will use the control panel, the sum control panel. We have to choose the distribution of the forces, as an instance triangular distribution and uniform distribution. To spare time, we are not considering the eccentricity of the center of mass of the structures, so in this case we will have faster analysis. To define seismic action automatically, we have just to click this command, force distribution. The program automatically generates the seismic load cases and also the load combination for nonlinear analysis. Then we have to use this command, seismic hazard, to give the program the information about the response spectrum. There is this wizard in 5 steps that collect all the information required by Eurocode 8 to define the response spectrum. So we have to set the importance factor, the seismic zone, and the reference acceleration. If we are considering unexisting buildings, it's required the acknowledged level and also the confidence factor. At step 2, we have to set the foundation soil category. At step 3, we have the eta factor, the set factor, and the periods of the response spectrum. So at the fourth step, we have the number of vibration mode that could be necessary for the distribution of the forces according to the vibration mode of the structure, but in this case we haven't chosen these distribution modes. And then at the last step we have the definition of the seismic masses that could be done by the program automatically. So in this table we have for each row the seismic load cases, and in each column the not seismic load cases, and this number tells the program which part of the loads is to be considered in the seismic mass. So we have one for dead loads, the self-weight of the structure, dead loads of floors and roof, and we have this code for live loads because the program automatically reads the factor from the archive of floors. Then we can click on OK to close this window, and on this command to run linear analysis. Before to run non-linear pushover analysis, it could be interesting to control the results of linear analysis in seismic load combination, as we did before for the vertical loads. This allows us to understand if our model is correct or not, because there are problems that could emerge only when we consider horizontal loads. In this case, the displacement seems to be correct, so our model seems to be correct. We save the data and we run the pushover analysis. To run pushover analysis from some control panel, we have just to click Run Analysis. The window of the solver automatically appears with the information about the load combination that is going to be analyzed. So we have just to wait the results of the analysis. Once the analysis is completed, we can open the monitor with this command. In the monitor we can check the capacity curve and the equivalent bilinear. Then with this vertical line we can check the point where the safety check is performed. With this command we can open the window with the acceleration displacement response spectrum. In this table we have all the data about the equivalent single degree of freedom system, the mass, the stiffness, the period, and gamma the transformation factor, according to Eurocode, that allow us to pass from the capacity curve of the real system to the capacity curve of the equivalent single degrees of freedom system. Then we have the yield force of the structure and the displacement in correspondence of the yield force of the structure. We have this ratio that allows us to calculate the behavior factor of the structure. It's the ratio between the multiplier of horizontal seismic action at the formation of the global plastic mechanism and that at the first plastic hinge in the system. this data with the letter D is the demand in terms of displacements for ultimate limit states, and this is the capacity also in terms of displacements. Then we have the safety checks, so the ratio between the capacity and demand acceleration for the ultimate limit states in this case. If the cell is green, it means that in this lot combination safety checks are satisfied, so the capacity in terms of displacements are higher than the demand. And then we have the same ratio, but in terms of return period instead of in terms of acceleration. The last data in the table is the ratio between the acceleration in the structure with unlimited elastic behavior and in the structure with limited strength. It's a data required by the Annex B of Eurocode 8. So you can refer to this regulation for further information about this data. In this graphic window, we can also have some information about the damagement that the structure suffered during the pushover analysis. We have this bar diagram that informs us about the number of elements that suffer a type of damage, compression or tension, shear, in plane, and all with means orthogonal out of plane, both compression and bending moment, in plane and out of plane, and elements which have problems in displacement. We have a displacement higher than their capacity. But we can also have a representation of this damagement on the structure. We have just to click on solid. So the element in gray are elements which didn't suffer the damages. Element in red are elements which has a crisis for attention axial action. And in orange we have elements which has problems for shear action. To better investigate the damagement on the structure, we can turn on or off some of the mechanisms. With this command we can move through the curve and see how the damagement on the structure evolves until the collapse of the structure, the last point of the capacity curve. So a brief recap of what we have discussed in this video. We have seen how to define loads and assign loads to the structure, how to check the results of linear analysis, how to run nonlinear analysis, and how to check the results of nonlinear analysis. In the next video of this series of tutorial about ProSum, we will see how to analyze, how to run nonlinear analysis on a reinforced concrete structure. Thank you for your attention. For further information about ProSum, you can contact us at assistenza@2sai.it for technical support and amministrazione@2sai.it for commercial information.